In this video, we will discuss about the indeterminate forms. Indeterminate forms. So this is also very important topic, indeterminate forms. So basically we define the indeterminate form as the limit of the function. We can say that limit of the function. We have the function in this form fx upon gx. When we apply as x tends to a, so basically you can say that the limit is equal to the limit of the numerator divided by the limit of denominator. Limit of denominator. So when we say that symbolically, the limit x tends to a fx upon gx. So we apply the limit separately on both the numerator and denominator. दोनों पे अलग अलग अप्लाई करेंगे तो fx upon limit x tends to a into gx. Now, what is the situation? So we see that if the limit x tends to a into fx, when we apply x tends to a into fx, or second limit x tends to a into gx, both are zero. Both are zero. So the quotient reduce to 0 upon 0. So 0 upon 0. So this is the meaningless, or we can say that does not exist word. So which is meaningless. Which is meaningless. Or we can say that does not exist. So we can say that limit does not exist. तो अगर इस तरीके की सिचुएशन अगर होती है दैट मीन 0 upon 0 फॉर्म, so we can say that this arise the indeterminate form. So now we have some cases based on this. So the form 0 upon 0 is called an indeterminate form. Called an indeterminate form. So other indeterminate forms are also. So other indeterminate form are forms are one is infinity upon infinity, second 0 into infinity, third is infinity minus infinity, 0 raised to the power 0, infinity raised to the power 0, or 1 raised to the power infinity. So these are the indeterminate forms. Now we move to the L'Hospital rule. So L'Hospital rule is also important for solving the problems based on indeterminate form. So we define as if a function fx and gx are differentiable in a certain neighborhood of the point A, except possibly x is equal to A. And if fa is equal to 0, ga is equal to 0, and the denominator of the derivative g dash x, which is not equal to 0 for x not equal to A. So then we can write down the limit x tends to A, fx upon gx is equal to limit x tends to A, f dash x upon g dash x. न्यूमरेटर का डिफरेंशिएशन न्यूमरेटर में और डिनोमिनेटर का डिनोमिनेटर. So we have the condition provided the limit on the right exists. So we take one problem based on this. So evaluate limit x tends to 0, x minus sine x upon x cube. So we do the solution of this. So when we put x tends to 0, so first we write down this as given limit x tends to 0, x minus sine x upon x cube. So when we put x tends to 0 in numerator, so this gives us 0 minus sine 0 upon 0, or sine 0 is also 0, so 0 minus 0 upon 0. So this gives us 0 upon 0. So 0 upon 0, this is the indeterminate form, means meaningless value. So this is the indeterminate form. So for solving this indeterminate form, we can apply the L'Hospital rule. So here this makes the indeterminate form, so we can use L'Hospital rule. So by using L'Hospital rule, the L'Hospital says that you differentiate numerator and numerator and denominator and denominator. So x minus sine x. What is the differentiation of x? With respect to x is 1. Sine x differentiation is cos x, or x cube differentiation is 3x square. But again we apply the limits. So again we apply the limit to 1 minus cos 0 upon 3 into 0. So cos 0 is also 1. So cos 0 is also 1. So that means upon 0, 3 into 0, 0. So this gives us 0 upon 0. So this makes again a indeterminate form. So we can write down again a indeterminate form. Again a indeterminate form. We can apply L'Hospital again until we remove the indeterminate form. So again L'Hospital. So again apply L'Hospital. This can be written a limit x tends to 0. One differentiation of 1 is 0, which is constant, or cos x differentiation is minus sine x. So minus minus plus, or 3x square is 6x. So again, when we use the limits, so this gives us sine 0 upon 6 into 0. So sine 0 is 0, or 6 into 0 is 0. So again, indeterminate form. So again, intermediate form. So we again apply the L'Hospital. So again using L'Hospital. L'Hospital. So again differentiate numerator and numerator. So what is the differentiation of sin x? Which is cos x, or differentiation of 6x is 6. Now we apply a limit cos 0 upon 6. 6 is constant, so cos 0 is 1, so 1 upon 6. So this is the answer, 1 upon 6. So this is a lengthy question that means taken 3 times L'Hospital rule we have applied. So such type of problems we can solve by using the algebraic methods also. So alternative method, that is the algebraic method. Algebraic method. So same question we can solve by using the algebraic method. The limit x tends to 0, x minus sin x upon x cube. So in algebraic method, just we expand. We expand sin x. So what is the expansion of sin x? So expansion of sin x is x minus x cube upon factorial 3 plus x5 upon factorial 5 minus and so on. So we use this expansion. So we write down as limit x tends to 0, x minus. So we use this expansion. X cube upon factorial 3 plus x5 upon factorial 5 minus and so on upon x cube. So here we can cancel x to x. So this we can write down as limit x tends to 0. So first term will be x cube upon factorial 3, second term minus x5 upon factorial 5 plus and so on upon x cube. So in this we can take the common x cube in numerator. So this can be written as x tends to 0. So x cube we can take the common. So 1 upon factorial 3 minus x square upon factorial 5. तो आगे के जो भी टर्म्स होंगे that contain x also. तो x contain करेंगे यहाँ पर x cube से क्या होगा, x cube cancel हो जाएगा. When we apply the limit x tends to 0 in this, so this gives us 1 upon factorial 3. So the value of 1 upon factorial 3 is 1 by 6. So other indeterminate form problems we will solve in next.